Okay, I think we can start. Hello everybody. Do you hear me well? Okay, so we can start. We are in week 8 and classification 2. Okay, so we go further with classification in this lab. We will basically review the methods you just saw in class, so the KNN and the decision tree. I will start by recapping what are those two methods. Then I will give you some basic examples. And finally, we will go through a more real example. We will try to classify drugs assigned to patients using, again, KNN and decision tree. Okay. Yes, that's it. So first of all, the recap. KNN and decision trees are very useful if you have such a problem with non-linear decision boundaries. Because in fact, if you try to classify using, for instance, logistic regression that we saw earlier, in this example, it won't work, or it won't work very good, because you are, with logistic regression and all linear classification methods, you will have only one line, if you can imagine, only one line to separate the classes. And in this case, this won't be very great. And that's why there are also non-linear methods such as KNN and decision trees. So KNN, what are KNN? This is very easy. So you have your training instances. And if you want to classify a new example, you take the K nearest instances and you let them vote. And for instance, if K equal 1, you take this one, so you classify it as in the first class, class 1 square. And if K equals 3, you take the 3 nearest. So K is the only parameter you have to set. You take the 3 nearest, and then you let them vote. So 2 versus 1, you assign it to class 2 in this case, if K equals 3. So, and K, of course, is typically chosen to be an odd number, such that the vote is partial. So there is no equality. And yes, so it can be anything, 1, 3, 5, 7. And we will also see how to choose the best one in the example below. Okay. So basically very easy. The only thing that could be a bit more difficult is to choose which type of distance do you use. And we will also see the basic one is the Euclidean distance, and we will see other ones. There is the Manhattan one. So you define your distance, you compute the distance to the K nearest instances, and you let them vote to classify a new example. This is the KNN. And you can imagine here that it works with, in this example, for instance, it will provide pretty good result, I think, because if the new instance is here, there is a huge probability that it's in the green class, versus the white class. So it works for problems with non-linear boundaries. Okay. Any question on KNN? There is one. It's all right. There is no questions. Okay, so I think it's not so difficult. And decision tree, we use a tree to classify new data points, and you build the tree on the training set. And at each node, you have to split, and you choose the split that maximizes a certain criterion. I don't know what you saw in class, but there are basically two: this Gini index or this information gain when you minimize the entropy. Yes, and is there someone speaking? Okay. So yes, decision tree. Oh, there is one in the chat. There is a question from Brian. Do you have to define each node? If there are a lot of features, wouldn't take that a long time. Yes, if you would do this by hand, but with the computer, it doesn't take a lot of time. In fact, at each node, at the beginning, you have the entire data set. And you take, for instance, in this case, is a person fit. So you have a list of person with their age and whether they eat a lot of pizza and exercise in the morning. And you try to find the best splits. So for instance, in this case, the first split, age below 30, is the best split. Because it maximizes the Gini index or the information gain, what you define, this criterion. If you would have chosen exercise in the morning, you would have obtained a lower Gini index or lower information gain. It means that the split is not optimal in this case. There is one more. A question from Inessa. The depth of this tree is 3. I think it's 3 or 2. We will see this. I think 3, yes, because there are 3. No, I think 2 because this doesn't count. So 1 and 2, just 2. I think it's 2. I'm pretty sure it's 2. But we will see. We will see. I will speak about the depth parameter, and we will see the depth of the tree below. Okay. Any other question on tree? So basically, you took the training data, and you find you separate the data according to the best fit, and the best fit is defined as the fit that maximizes a certain criterion. So in this case, all people with age above 30, the best criterion is whether they exercise in the morning or not. And in this case, the best criterion among people below 30 is whether they eat a lot of pizza in order to classify them as fit or unfit. Okay, any other question on decision tree or KNN? Question from Pierre, can we use any kind of data type when using a tree? I guess you mean like, do we have to encode the data before using a decision tree? The answer is yes, we have to encode the data before using a tree. because these criteria are mathematically computed. So you have to make the data, to make the data numbers, basically. We will see this, we will see this. Okay, let's go for the basic examples. I import some packages, Panda, you know this. Plots, Seaborn, NumPy, and some metrics, confusion matrix and accuracy score. Then I customize my plot to make them beautiful. And we can start with KNN. So it just canceled here. Okay. So I created data from scratch. We have 16 points in the plane 1, 0, 1. And point with low value of both x1 and x2 are associated with class 0. And points with higher value of x1 and x2 are associated with the class 1. So 16 points in total. And we also have 3 points for which we don't know the class. So, but we can already imagine. So P1 should belong to class 0 because it's low and low. P2 should belong to class 1 because it's high and high, closer to 1. And P3, we don't know. It's difficult, maybe 1, maybe 2, we don't know. Of course, we can plot this. So I do a scatter plot of the data, and I colorize the data with the target. And I also plot the points for which we don't know the class yet. And this yields something like this. So we clearly see the 2 classes, in red class 0 and in blue class 1. And we can imagine that P1 belongs to class 0 and P2 to class 1. And for P3, this is more difficult to say. Okay, then we select our X and Y. So X1, X2, and Y is Y. And we use this K-enable classifier from sklearn to run the algorithm with a K from 1, 3, and 5. And we plot the results. So we fit the model X and Y with the K that we chose from above. And then we predict for the points for which we don't know, and we plot all the thing. And this gives us something like this. And we can see, for instance, with k equal 1, so if we take only only one neighbor, the nearest one, this classify P3 in the blue class, because this should be, or this one is nearer than this one. If we have k equals to 3, we also have P3 in the first class. Of course, the other points are always in the respective class because they are very close to the points, the class they belong. But if we choose k equal 5, we can see that the points turn red. So the algorithm classifies the points in the class 0, the red class, because it took basically the 5 instances here and let them vote, and 3 versus 2 is then red. So the 3 wins. Okay, that's it. This shows a bit how it works, and that sometimes with different k you can obtain different results. Okay, any question on this basic example? Okay, if there is no question, we can do a basic example for decision tree. So I change here the style of the graph of the plots. And I have here 3 examples. The first one, so we want to predict the salary class, 1 or 0, based on some attributes, characteristics of people. So the degree, apprenticeship, master or bachelor, sex, 0 and 1. And we also have, for the other examples, for example 2, we also have the age of the person. And so we want to classify the salary class. For the first example, we can see, for instance, that all masters, so we have to do a 3. So we have to use one of those one of those columns, attributes, feature, to do a split. For instance, we can do, okay, sex equals 1 is class 0 and sex equals 0 is class 1, but it doesn't work in this case because we have, for instance, here we have 1 and 1, here we have 1 and 0. So it doesn't work well. But what works well, we can see in this example, is that, for instance, all master are classified in class 1. So if we split master versus rest, we already have almost everything done. So 1, 1, 1, and 1. Only this one is remaining. And then if we go to the second and take sex equals 0 is classified as 1, we can see that for the rest, all 1 are 0 and all 0 are 1. So you can do the classification like this in this case. So what I wrote here. So a human could do the classification. This is quite easy. Okay, we will go further with the first example. So I encode the categorical feature using one-hot, as we already saw in previous labs. So this is something like this. Then I concate the tree, the data frame, sorry. So we have done something like this. I select X and Y, and I do the classification. So from sklearn, I import the decision tree classifier and plot tree. This is useful to plot the tree. We will see this. I fit and I compute the score. So this is the accuracy score. And then I plot the tree. Okay, let's run this. So we have, as I mentioned, an accuracy of 1, because we can do a perfect classification in this case, because it's a basic example. And as we saw, if I also run this, it takes like x3, so the index 3 of x is 0, 1, 2, 3. This one, the master. If the master is below 0.5, it goes further, and if it's above, it classifies it in the first class. So this is what we have here, and then it takes the 0, so index, this one. If it's below 0.5, it classifies in the class 1. This is also what we have here. This one is in the class 1, and the 5 remaining, all the rest that is not master and not sex equals 0, is classified in the class 0. So we have a good classification in this basic example. Okay. Any question on example 1? What is the tree depth, 2 or 3? The tree depth. I think we can do something like this. This should be 2, but I can check this by doing 3 dot get depth, or maybe something like this. 2, yes, this is 2 in this case. So it means that, yeah, so this is the number of splitting layers, if you wish, so 1 and 2, because they could have been one more split here. and this would have been also 2. So 2 is really good because we have 2 classes and 2 splits. So and a def of 2. So this is basically good. Okay, there are other questions. Yes, to count start from leaf 0 to the I guess the node the most the farthest node. So maybe this one. So this makes 1, 2. Okay. So let's go for example 2. So I change this. And in this case, this is more difficult to see because we have, for instance, if you want to use degree as first splits, apprenticeship is 0 and 1. This is not so good. Bachelor is also 0, 1, 0, 0. So you have this one. Master is 0, 1. So you don't have, yeah, you cannot choose a split, but you don't have to always have a perfect split. But at the beginning, it's great to have a split that really separates 0 and 1. Sex is the same, so you cannot really split in an optimal way. But if you look at the age and take all people below, as I wrote here, all young people, so below 25, they all belong to class 0. So below 25, below 25 is 0. This one is not below 25. This one is below 25 and is 0. This one, not this one, not this one, not this one is below 25 and is 0. So it makes already 1, 2, 3, 4 out of 10 is a good split. For instance, in this case. And if we run the whole code, we can see that the tree will do this. I wouldn't have guessed this without looking at the tree before, of course. And if we look at this, so it makes the first split age below 25. So we have a 4 instance. Then it takes the age below 38.5. And we have 3 in this case. And then it takes as a last step age below 53.5, and it makes the last split. So it only uses this DH in this case, and we also have an accuracy of 1. The def is 1, 2, 3, so a bit more complex, the 3. And yes, so sometimes it's more difficult in real life. Okay, there is one question. Yes, the question is, do we need to split the data in X train, Y train, and so on and so forth? Of course, we will have to do this, but this is a basic example. We don't have any train set and test sets. In this case, we only show how it works with basic example. Of course, in general, you will have to split the data into training and test set, and I will speak about that because in the case of trees, this is very there is stuff we have to take care about. Okay. So sometimes this may be more difficult in real examples, as shown in. Okay, there is another interesting question. What does the Gini value represent? I think you mean this one. This is what is maximized. So if you do the splits at, if you use this splits below 25 and above 25, you will obtain, if you compute the Gini index of it, I can show you afterward what it is. You obtain a value of 0.48, and this is the value that is maximized. So if you take this split, you maximize the Gini. That's why you use this. splits. So among all splits, this split maximizes the Gini, and the Gini is like an information criterion. So it's it quantifies the optimal weight to splits. And if you maximize this, if you maximize it, it means that you do the best splits. And I have something, I guess, here, yes. So you use either Gini index and information gain. You can read this article that is here if you want to know more about this. Basically, this is information gain is like the reduction of entropy, the reduction of disorder, which is basically computed like this, and the Gini index is like something like this. Yes, this is basically, as it's written here, it is the measurement of the impurity or randomness in the data point, the entropy. So if you look at something that minimizes it, so you minimize the randomness in the data points. Okay. So yeah, you may read this article if you are more interested what exactly entropy and Gini index is. Okay. Third example. The third example shows a case where there is basically no pattern in the data. For instance, if you would like to classify in this case, apprenticeship is 1 and 0, you cannot split, so it's basically not so good. Bachelor is 1, 1, 0, 0 is not so good. Master as well, 0, 1, 1, and school, okay, school, why not? And the same for sex, so you have 0, 1, 1, 1, 0, 0, 1. So there is no clear pattern in this case, in this example. So if there is nothing to discover, if there is no pattern to discover, this may be very dangerous to use a decision tree. We will see also after why. Yes, so if there is nothing to discover, the algorithm will discover nothing. And if we look at the tree, so we obtain an accuracy of 0.7. And if we look at the tree, we end up with a very deep tree in this case. 1, 2, 3, 4. So not very deep, but deeper tree as the previous examples. And this, yes, if you end up with a deep tree, and a deep tree would be defined. This is a question for you for after. But if you end up with a lot of nodes, a lot of great depth, then you may ask yourself, maybe there is nothing to discover, like in this case, or even worse, you are maybe overfitting. If the accuracy, this is not the case here, but if the accuracy would have been 1, and you end up with a very deep tree, then there is a big probability of overfitting. And the solution to avoid it is to find the best hyperparameters is to use cross-validation. But I can explain a bit more here. But first, a question for you, maybe. Can someone explain what is a deep tree? Okay, if there is something in the chat. Lucas says with a depth value over 3. This is partially true. The number of steps to classify all values, this is also partially true. method to classify. I don't understand this. A deep tree depends on how many classes you have. So for instance, if you have 2, the best split is always 1. If you do a perfect split would be 1, a depth of 1, because you split everything first class, second class. So the best split is always n minus 1, where n is the number of classes. So what is a deep tree depends on the number of classes you have. If you have 5 classes, a tree of depth 5 is fine. A tree of depth 4 is optimal. A tree of depth 5, 6, 7 is fine. And more than that, you may begin to ask yourself, okay, is my tree too deep? So it depends. It depends on the number of classes you have. And in this case, we have 2 classes. So the optimal tree has a depth of 1, because you would have classified, but it's not always the case. So as a depth of 1, so class 1, class 2, or a depth of 2 is also fine. So class 1, and then as shown in example 1. If I come back to example 1, the depth was 2, and this was fine. The tree is not too deep. Is not too deep. So yes, it depends on the number of classes you have. And if we go to this interesting article, yes, it says how to find decision tree depth via cross validation and to avoid overfitting. Because if you have an accuracy of almost 1 and a very deep tree, it means that you have a big probability to have overfitted your training sample. So you classified everything, but this won't be appropriate to classify new instances, because at the end you only have, for instance, some only if you have, for instance, 200 instances in your training data, and the majority is classified within a depth of 3, and the rest of the nodes are only for 10 remaining instances. These nodes are not very useful, and they are overfitting your training set, if you understand what I mean. Yes, an overfitted tree would achieve a perfect classification of the training observation, and the BSR would be 0. But if you overfit, then it does not apply to the test data. So the test accuracy would be very low, or not very low, but not 1. And we want to avoid it. We want to have something, an algorithm that works well in the majority of the cases, and does not overfit the training data. And to avoid this, we can use cross validation. And what is this? Basically, you split your training data into k folds, in this case 5. And in the first, and you want to find the optimal parameters. In this case, for instance, this is the optimal depth. Find the optimal depth. So you train the data on the fold 2 until 5, and then you test. So you predict for fold 1, and you have your accuracy, and you do this for all the parameters you want to test. So for instance, if you want to test the depth from 1 to 20, you do for the first split, you compute the accuracy with a depth of 1, 2, 3 until 20 on this data. Then you do the same for this one, the same for this one, the same for this one, and the same for this one. And then you compute the average accuracy per depth. So you have, for instance, you have the average accuracy for a depth of 1 among the splits. And the model, the best parameters is the parameter that have the best accuracy, the best average accuracy, for instance, among the splits. So again, you split the data into 5 to 10 in general folds, and then you do like this. So you train here, then you test, get your accuracy for all the parameters of the model. Do the same, you train using 1, 3, 5, 4, and then you test on 2, and then you have your average accuracy per value of parameters. And at the end, when you have your optimal parameters, you can do you can train on the whole training set, on the whole training data, and then test on your test set. We will see this. We will see this how to do this in section 3.4. There was a question in the chat. Okay, thanks. So there is nothing. Okay, any question on cross-validation? So the way cross-validation is very useful to avoid overfitting, because you always have another training data, and also to find the optimal hyperparameters of your model. In this case, in the case of a tree, basically the depth, the maximum depth, because you can choose the maximum depth, and you want to avoid that the tree is too deep, and that at the end the nodes are classified only like 2, 3 examples and overfit the training set. Okay, any question on cross-validation? Okay, if there is no question, I have the participation exercise for you now. So I will break out the rooms, but first I will explain. And then you have to send your answer and code on Slack. It's better on Slack than Zoom private. But you can also, of course, send me via Zoom. Okay, and people who submit the correct answer will get the point for the participation. A question: is it one code for the whole group? I don't know. Let's do one code per person, but we have to submit it like last time. Conditions change. Let's do one code per person, but you work in group, and you also write the name of the group members in your submission. But everybody has to submit, so that I can write the names and it's better. So the example, the data set is about fruits. So we want to classify. There is something else in the chat. Thanks. Okay. Okay. Do we work with our group for the final project? No, I will. Professor Vlachos told me to break out to do this breakout session, and I will do this in group of 3 or 4 people. Okay, so the data we have, we want to classify some fruits as orange or apple, and based on width and height. And if we plot this, we see that we have like, it would be great to have a nonlinear algorithm, because if we want to draw a line here, this doesn't work very well. So maybe a non-linear, so maybe one line here, one second line here, and one third line here. Non-linear ones, this means non-linear, would be better. And the question is to classify. So we select X and Y, and we want to classify first using logistic regression. So logistic regression is linear, a linear algorithm to show that it doesn't work well. It doesn't work well. And then we want to classify using a decision tree. And of course, you want to plot the tree to see the depth and the train accuracy in both cases. Okay, so I give you 20 minutes, I think, and let's break out the rooms, the session. Okay, but first there may be some question on the. Okay, a question. We have 1 week to do. No, this is until today evening, so this is really participation. But I give you time now, so until 4:20. But first, let's breakout session. So let's do like this. 10 is fine. Okay, so let's break. And yes, 20 minutes, so until 4:20.
bonjour madame, ici monsieur Corot de Recyclage Express. Je vous appelle parce qu'on a un transport qui est prévu ce vendredi. On
Okay, I think we can continue. If you are not done with the exercise, you can just submit it until today evening.
Sorry, just to repeat, I guess, like, I mean, we are going to submit you the whole collab, right?
No, you just submit me a screenshot of the exercise or something like this in Slack, and everybody has to submit it. And there is also a question in the chat: did you want us to do a train test split for this exercise or not? No, this is just again a basic example to illustrate the difference between logistic regression and decision tree in the case of nonlinear boundaries. For those who did this exercise, they already saw that the accuracy of the logistic regression is quite low, and the decision tree has a great accuracy, just because it's nonlinear versus linear classification algorithm. And everybody has to submit in Slack.
So you want capture or the code copy and paste? It's
both.
okay?
Both is okay.
Okay.
Screenshot or code is okay. Okay, we can go. We can continue with the drug classification. Okay, so we want now to use a real life example, and to classify patients into drug categories according to their individual attributes. So for instance, age, sex, blood pressure, cholesterol level, and sodium to potassium ratio. And so we want to predict the drug the patient used based on those attributes, features. Okay. So we have 200 people in this data set. And if we describe it, we can see that the age ranges from 15 to 74, sorry. And the ratio, even if it does not so, it's not so, it doesn't say a lot of information to us, but the ratio is like from 6 to 38. Okay. We first want to plot all variables, so I use subplots, and I use the count plot if the data type is objects, and otherwise I use istplots from Seaborn, and those index are just to correctly put the plots in the right place. For instance, that we all have that we have this one here and this one here. Okay, so we can see the age ranges from 15 to 74, cholesterol high and normal around 100 per class, sex around 100 and 100 is also equally in the sample, the sodium to potassium ratio, and also the blood pressure, and what we want to predict the drug class with a lot of instances in the Y class. So a question for you, this should be easy now. We did this a lot of time. What is the base rate in this case, if someone wants to write it in the chat, how to compute it? So basically the base rate is what you would obtain without algorithm. So that's the prior probability of the most common class, this one. So it is around 90 something divided by 200, because you would classify everything in this class if you wouldn't have any algorithm to have the greatest probability to be correct. So if someone can just write how to compute it in the chat.
Sorry, what is the label feature, you mean?
So you have to tell me what is the base rate in this case.
Yeah, I mean, what is the label? The label, which feature is the label? I mean, drug or the cholesterol?
So we want to predict the drug the patients are taking according to those characteristics. So this is the Y, this is the one what you want to predict, and this is the X's, those
Okay.
ones. There is one suggestion in the chat from Diana. I think Aliu is right with 45%. This is something like this. So this is the probability of drug Y. So, so this doesn't work. So basically this is, I will try to, okay, to copy this. So you take the drug value counts. If you do the value counts method, you obtain the value count. So you have 91 for the most common, the Y class. And if you do this, I try to do this. I don't know if it would work, but I guess it works. So if you do this, you obtain, yes, the probability of all the class, and you take of all the classes, and you take the most common one. So this is our base rate. This is what we have to beat, to outperform in order for algorithm to work. So 45.5%. Okay. We can use a per plot to show something very interesting in this data, and this also shows that data exploratory data analysis is very important, because you can already get a lot of information from your data. So in this case, for instance, we see that all people with NA to K ratio above something like 15 are all take the drug Y, so this drug, and this of course will be useful for classification, and in particular in the case of a tree, because you would have your first. This is clear that you will have your first decision boundary. Your first split will be here, because it's already classify everybody, like 90 people. Almost, because there is some rest here, but like 90 people of the drug Y class directly in this class if you use these attributes. Okay, the next step is to prepare the data for the algorithm. So we have our data, and we need to encode some of the stuff. We do this here: sex, blood pressure, cholesterol, and drug. we encode them. This means we use label encoding, and this means we put numbers according with the class. So label encoding, basic. We use like as always the train test splits. This time with a test size of 35%. And we select, of course, the X and Y. So we take the drug, we want to predict the drug, and we drop it so that we have our X factors, and we end up with an X train of 130 rows, 130 people that we want to predict the category for. Okay, any question on this at this point? So basically, as always, you encode, you split, and then you train the model. But in the case of KNN, there is one step that we have to do is to normalize, because we use distances between the points. So we have to normalize the data. Normalize means we rescale the data between 0 and 1. Basically, this is. So if we do this, so we use the min-max scala from sklearn. We create an instance of the class with it, and then we transform the X train, and then transform X test with the same. We fit on the training set. This is also very important. We fit on the training data, and then we transform the training data and the test data. We don't fit on the test data, otherwise it would be cheating. So we can see that it rescale everything between 0 and 1. So this is, for instance, the age. So basically, it is very easy. It takes every line, and for instance, for the age, it does something like this. So for all age, it divided by the minimum and the max, something like this. So it resizes between 0 and 1. I can show you the equation exactly. So it subtract the min and it divide by the min minus the max, something like this. Something like this. Yes, it's for instance, it takes all ages and it removes the minimum and then divide by max minus min of the age on all features, basically. So you don't see this because maybe you don't see this because. Could you see this on the min max scalar? Okay. So basically, it takes all values and remove the minimum and divides by max minus min. So that everything is rescaled between 0 and 1. There is one question: would have standard scalar also worked? That's a good question. I guess yes, but this is not as precise as min-max scalar in this case. Because standard scalar is really to standardize the data, so it makes min of 0 and standard error of 1. But I guess this would also work, but min-max scalar is better because we compute distances, so we all want the same range for the data, basically. And the type of distances we have, we can go in the KNN class and see what do we have for distance. basically this is this Minkowski, and if I, how do you write it? Minkowski, something like this. Basically, this is something you have to specify the p parameter, and this is something like this. So this is the absolute value to the power of p, the sum of it, and then you take the power 1 over p. So basically, if the p is equal to 1, we have the Manhattan distance. So the sum of absolute values. Basically, this is the sum of absolute values because 1 and 1 makes nothing. And if p equals 2, we have the Euclidean distance as written here. So the sum of squares, the square root of the sum of the squares but you can specify any p you want, and this is the basic distance measure in this case, in the neighbor classifier. And in this case, the distance is the Euclidean distance with a p of 2. This is the by default distance. So this is the Euclidean distance. But you can also specify what you want in the distance metric, so you can see the documentation and so on and so forth. But this is not very important in many cases. So, but by default, this is the Euclidean distance. So we fit the model once we have normalized. We fit the model with we try with k of 5. And then we predict as always, and we evaluate the model with the accuracy and the confusion matrix. And this yields an accuracy of 0.7, I think. Yes, 0.7, which is greater than the base rate. So we have some, we are fine. And this is the confusion matrix for this case. And of course, in order to define the best hyperparameter, as I said earlier, we can do what is called this cross-validation, where we use those folds. We split the training data and we run for all the hyperparameters, and then we can we take the average, and then we can choose the best model and use it for the prediction. And in this case, we want to test for a k value of 1 to 100 or 99. We want to test the p value of 1 to 3, and the weights. The weights means if the nearest neighbors have more voting power than the neighbors that are less close to the points. So if we take uniform, all neighbors will have the same weights, and if we take distance, this is weighted based on the distance to the instance we want to classify, where the closer points have a more importance for the voting. And we do this, so we define the model. We also define the cross validation. We use in this case 10 folds, and we pass the grid that we defined as arguments in this case, and we fit, and we want to see the best parameters and also the training and the test scores in this case. Yes, okay. And if I run this, it takes a bit of time because it has to run a lot of models. 2 times 2 times 99, sorry. And we end up with the best hyperparameters with 1 neighbors. So you take only 1, k equal 1, P equal 2, this means we take the Euclidean distance and the weights are uniform. So no, they are not weighted on, this is not weighted on the, based on the distance. Okay. There is one interesting question. How do you choose the CV value? You can choose, yeah, in general, you take like 5 to 10, but it also depends on the, number of examples you have in the training set. If you have a very small training set, if you take a lot of, this is better to take more, and also you don't want to take a lot, so you don't want to take a small, a too small amount, because this you wouldn't have many training data, and you don't want to take a great too big number, because you want to have a test set that is great enough. If you understand what I mean. So you don't want to take too little, because this would mean if you take too little, the too little folds, the training data is too little, and there are too few instances in the training data, and if you take too much, too great number, then your test data in each fold will be too small. Should be at least 5. No, it depends really on how many data points you have in the data set. For instance, if you have a data set of 100 points and you take 3, you would have for each data like hundreds. So you would have a correct split. If you take 5, you would have a correct split. You would have 80-20, like training data 80, 20. If you take 10, you would have 90% of the data in each fold to train, and 10% to test. So you take between 3 and 10 is fine, because if you have 3, it means if you have 3-fold, it means you train on 66% and you test each time on 33%. And if you take 10, 90, 10 is also fine. So it depends on the size of the training and test data you want in each fold, basically. Okay, did it answer your question? Okay. So it depends on the size, it depends on how much percent you want test data and training data, basically. Okay, and then so we obtain a test score of 0.81, which is better than the 0.7 that we had with a K of 5. So yeah, that's normal because we optimized it, and we can also so use it to fit the optimal KNN model in this case. So we end up with this confusion matrix and an accuracy score, as previously mentioned, of 81.43%. Okay. Any question on this, on cross-validation, on anything? Okay. And last but not least, the decision tree. So in this case, we do basically the same. So we don't use the normalized data because it is not necessary in this case with a decision tree. So we fit the model, we predict, and we evaluate the model. And this yields a very good accuracy. of 97, basically only 2 in the training. No, this is in the test set, so this is a very good test accuracy, and basically only 2 instances are incorrectly classified in this case. And I guess the training accuracy is 1, and in this case, if you have a decision tree, as I mentioned earlier, if you have a decision tree with an accuracy of 1, you may ask yourself, okay, do I overfit? And how do you check this? In this case, we don't overfit because we also have a very high accuracy in the test sample. So in this case, we are fine. But if we would end up with a lower accuracy like 80, we should think about lowering the max depth, because the nodes at the end, the last splits wouldn't be so would be overfitting the training sample. But in this case, this is not the case. Okay, we can plot this and see that we have a depth of 1, 2, 3, 4, which is optimal, knowing that we have 5 classes. So we are not in the case of a deep tree, since we have the minimum depth possible with not the minimum, but a very small depth, lower than the number of classes. And of course, we can see what we mentioned earlier, that the first split is this Y is this X4, so this sodium to potassium ratio. If I run this, so I take only the first split, exactly. So I take the training data, X train and Y train, and I take the training data where the ratio is above this value. So this is the first split. Above this value, it classifies everything 61. We have 61 instances, and we also have here 61 people that are this is almost the half of the training data that are in the first step classified as drug 0, which is drug Y. So what we saw earlier. So that's why this is the best split in this case, because it classifies like directly in the Y class. And that's also why EDA is important, to know which algorithm to apply and so on and so forth. Okay. Okay, and we also have the score, which in this case is 1 for the training set. So there is a path that classifies everything correctly in this case. And as I mentioned earlier, we are not in the above mentioned case of overfitting, because we have first a good result in the test data, and second, we have a depth of 4 with 5 classes, which is optimal. But of course, with real life data, this may be different. And this means grid search and grid search cross-validation is not useful in this case. Otherwise, we would have tried to optimize the depth using this cross-validation method that you can see in the article I mentioned above. But of course, we can try with different depth, 1, 2, 3, or 4, and see what is the accuracy. So we fit a decision tree classifier on X train and Y train with the depth, with the max depth equals to the depth, 1, 2, 3, or 4, Then we predict and we print the depth, print the accuracy score, and plot the tree. And we see that basically it always do the same split. This is also normal. And so if we would have only a depth of 1, we would end up with an accuracy of 0.7. It would do only the first split that I mentioned earlier. And if we, then this is for a depth of 2. So the second split is x2 below 0.5. What is x2? X2 is 0, 1, 2. So this one, this blood pressure. So 0, 1, or 2. And this is the second split. Then there are 2 nodes, and finally 3. And we obtain a depth, an accuracy of 0.8183. So you see this step lowers the accuracy. This can happen. And finally the last depth where we have a perfect classification for the training data and an accuracy of 97% for the testing data. Okay. Any questions on KNN decision tree? Anything that was unclear that I should explain or re-explain or try to? So yes, I recommend really to read this this article right at the beginning, this one, because it summarizes everything regarding decision trees. So what is a decision tree? How to train it, this Bayes variance trade-off, overfitting, cross-validation, and there is also an example a bit complex because you can use this cross-validation class, and I don't know why she doesn't, or why Michel doesn't do this. And then you have the accuracy, the average accuracy, the mean accuracy in the cross-validation folds, and he sees that this is for the depth, the depth that maximizes the average accuracy in the training folds is 5 in this case, for instance. Then he took a 5 and he trains on the test set and obtain like this. Okay, I recommend reading this. Okay, so I think there is one question. What does the value vector in the decision tree represent? What do you mean? Okay, the value, this one. If we took this, we will take the example that we just did. So here, for instance, the value is how many instances are in each class if we do the split. For instance, here, if we do the split, we obtain like about 61 in the first class, 0, 0, 0, 0 in the class. So at the beginning, you have 61 instances in this class, 14, 10, 11, and 34 instances. If you do this split and you go here, you have 61, 0, 0, 0, 0, and then the rest. It means that this is then 0, 14, and then next split, you do this split, you obtain 0 and 0. For 14 are all in this, the 10 are all in this, 11 are all in this, 40, 30, 34 are all in this class, and so on and so forth. So you do the, so it gives you how many instances are in the class after the split. So I guess you understood. Okay. Okay, I will stay in the session like 10 minutes. We are done. Thank you for attending the class. I will stay like 10 minutes to answer if there are questions. But basically we are done. So have a nice evening and see you next week probably. Thank you for attending the class. Ciao. Bye.